Hello, welcome back to Strife Dude. Some math. Today we're going to be working on graphing and solving quadratic inequalities. Now, quadratic inequalities look something like these formulas that I'm writing down here. We have y is less than ax squared plus bx plus c. So it just looks like our standard quadratic equation. Instead of an equal sign, we have less than or equal to, greater than, and greater than or equal to. So when graphing these quadratic inequalities in two variables, we have these 4 steps that we can follow. Our first step is to graph the equations, like we normally do in previous sections. We just got to make sure to use a dashed line for less than or greater than, or use solid lines for less than or equal to, or greater than or equal to. For the second step, we're going to test using a point of our choosing on the inside of the parabola to see if it is a solution to the inequality. And then our third step, we're going to shade on the inside if the test is true, that it is a solution to the inequality. If it's not, then we're going to shade outside our parabola. So shade inside. If not, shade outside. So that was actually all 3 steps. If we're graphing multiple quadratic equations, we need to shade where they overlap. So let's do some examples. So we start off by listing our a, b, and c values, because those are usually useful in quadratic equations. To find our vertex, that is x equals negative b over 2a in a standard form. So I'll get negative 2 over 2 times 1, which is negative 1. After that, we plug it into the equation to find our y-coordinate of our vertex. So we get 1 minus 2 minus 8, and that equals negative 9. So our vertex is at negative 1 comma negative 9. Our pattern is always 1a, 3a, 5a, 7a. Our a value is 1, so our pattern is going to be right 1 up 1, right 1 up 3, right 1 up 5, and so on. Now we got to determine whether or not it's a dashed or solid line. Our greater than symbol tells us it's a dashed line. I ended up making it solid, but it's supposed to be dashed. So I start at negative 1 comma negative 9. I go right 1 up 1, make a dot, right 1 up 3, right 1 up 5, right 1 up 7, and then reflect it over to the other side. Now we're going to test the point 0, 0 because it's inside the parabola, but it's an easy point to work with. So I'll get 0 is greater than negative 8, and that is true. So we're going to shade on the inside. Alright, next problem. Alright, so we started out with 2 equations. Let's work with the first one. Y equals x squared, that's vertex. Since our b value is 0, we plug in 0 and get 0. So 0, 0. Our pattern is a typical plus 1, plus 3, plus 5. And it's a solid line because it has the greater than or equal sign. For our second line, our vertex, our b value is still 0. We plug it in and get 0 plus 5, which is 0 comma 5. For our pattern, it's going to be negative 1, negative 3, negative 5, because our a value is negative 1. So I'm going to graph this first one in red. So the top one. Start at 0, 0, go right 1, up 1, right 1, up 3, right 1, up 5, and so on, and then create our solid line. For this next one, I'm going to graph it in green. So we start at 0 comma 5, which is there. And I'm going to go down, or right 1, down 1, right 1, down 3, Right one down, 5. Whoops, I made it a solid line. Let me fix that. It's supposed to be dashed. So here I go, using the undo button, making it dashed. Okay, now we can test our points. For the red, I'm going to test 0, 1. I can't use 0, 0 because it's on the line. So 1 is indeed greater than 0 once I plug that in. So yes, that works. For the green, I'm going to test 0, 0. And when I get 0 plus 5 is 0 less than 5. Yes. So I'm going to shade on the inside of the red and the inside of the green. And that makes, if we mix those two colors together, we get yellow. Ta-da! Alright, no more graphing. We're going to solve them algebraically this time. So first thing you got to do, write it as equation. 2x squared minus 7x equals 4. So we just got rid of the greater than symbol. Then we're going to switch it to standard form by subtracting 4 over to get 2x squared minus 7x minus 4 equals 0. And then we're going to find our critical values, or x-intercepts, whatever you want to call them, by either factoring or using quadratic formula. Solve for x. So I'm going to write it down here. So I got 2x squared minus 7x minus 4 equals 0. When I factor it, I'm going to get 2x 2x plus 1 and x minus 4. And set that equal to 0. So either 2x plus 1 is equal to 0 or x minus 4 is equal to 0. So you're going to get x equals negative 1/2 or x equals 4. So the next thing you got to do is plot your points. So there's negative 1/2 there. And then I got 4 there. I'm going to do open dots because we have a greater than symbol. And now we got to test points. So you want to test points in all 3 sections. So you want to test the left side, which is negative 1, the middle, which happens to be 0, and then the right side, which is 5. When I plug in all those into the equations, and we'll get that it'll work on negative 1 and positive 5, so I'll shade in those directions. Alright, next problem. First step, once again, write it as equation. So 2x squared minus 5x minus 3 equals 0. Remember step 2, put it in standard form. Done. Third step, I'm going to go factor it, or you can always use the quadratic formula. But this factors into 2x plus 1 and x minus 3. When you set them equal to 0, you'll get x equals negative 1/2 and x equals 3. So fourth step is to plot them. This time I'm going to have solid dots on negative 1/2 and positive 3. And I just noticed there's a sixth step. Sixth step is write the inequality solution. So let's back up to the previous problem. So I'm going to have x is greater than 4 and x is less than negative 1/2 for that one. So let's go back into here. So I'm going to test the left, which is negative 2. So I'm going to plug that in and get 2 times negative 2 squared minus 5 times negative 2 minus 3. So I'm plugging it into my equation. And I get, and I want to see if that's less than or equal to 0. So I got 8 plus 10 minus 3. Is that less than or equal to 0? Yes, it is. Or no, it's not. 15 is definitely not less. So I'm going to test the middle in between negative 1/2 and 3. And that one's an easy one. Negative 3 is less than or equal to 0, so yes. Now I'm going to test to the right of 3. So I chose x equals 4. I got 32 minus 20 minus 3. 9 is definitely bigger than 0, so no. So I'm going to shade in between. So I'm going to get x is in between negative 1/2 and 3.